In today's session, we will learn to find the distance from the velocity time graph. So here's the graph of a body. This is the graph of this body which gives us the velocity of the body. Now let us answer a few questions before we start the graph. The first question here is, what is the velocity at 3 seconds? Now from the graph, how are you going to find out velocity at 3 seconds? Now where is 3 seconds? Here is 3 seconds. This is the time axis. This x-axis is a time axis and this is 3 seconds. So from 3 seconds now, we will go up to the graph and see what value I get. I reach here. So at this, what is the value of the velocity? It is 4 meters per second. So let me write that answer. At 3 seconds, the velocity is 4 meters per second. Now let's go to find the velocity at 7 meters at 7 seconds. So where is 7 seconds? Here is 7 seconds. Then I go to my graph. So here is where I meet the graph. Now let us see what is the velocity for it. So I go to the velocity graph here. So at this point, so again it is 4 meters per second. Now next I will go for 0. So where is 0 on my time graph? On my time graph, this is 0. This is 0 time. Now I find out, I go to my graph here to find the velocity. The velocity at 0 is here. So that means this is also 4 meters per second. Then we have to go for 9 seconds. So first we'll see on the time graph where is 9 seconds. Here is 9 seconds on the time graph, okay? And then we go to the velocity time graph here, and we try to find the velocity. We go to the velocity graph here. So it comes again at 4. So here also the velocity is 4 meters per second. So this is a graph of a body moving with a constant velocity. Same velocity, constant velocity. So it does not change, is no change in direction. Constant velocity means no change in direction, no change in speed. This is the story that this graph tells us. It tells us that this body is moving with a uniform velocity of 4 meters per second. That it is not changing its direction, it is not changing its speed. That means the motion must be uniform. It covers equal distances in equal intervals of time. It is moving with a speed of 4 meters per second, which means 1 second it always moves 4 meters. In the second, it will also move 4 meters. In the third second, it will also move 4 meters. So it is going with a uniform speed, and such motion is called uniform motion. Now from the same graph, we are now going to learn how to find the distance covered by the object. So here's a question. Find the distance covered between 0 second and 5 second. So this is what you do. First you mark the 0 second. So here is 0 second. And then we need to do 0 second to 5 second. Now we need to mark our 5 second. So this is 5 second. And now we'll draw here to the graph and see this area. This area, this entire area enclosed by the velocity time graph will give you the distance covered in 5 seconds. So this is area equal to distance covered in 5 seconds. That is from 0 second to 5 seconds. And how do we find this area? This area will be length into breadth, right? So the area will be length into breadth, and we see the length here. This length is 5, so I put 5 here, and the breadth here, this breadth here is 4, so into 4, so the area will be 20 meter square. So distance covered will be equal to 20 meters. So again I repeat, this is the length from 0 to 5 is the length, and this is my breadth from 0 to 4. That is the area of this entire area of this rectangle. Now for the same graph, now we'll find the distance covered between 2 seconds and 8 seconds. So let's mark out 2 seconds and 8 seconds. So 2 seconds is here at this point, and the 8 seconds is here. So the area below the velocity time graph will give us the distance. So let us mark the area. So this is 2 seconds here till the graph. So this area enclosed by this will give us, so we'll just color the area. This area, this whole area will give us this distance between 2 seconds and 8 seconds. So again, this area like A, B, C, D will give us the distance traveled. So this is distance traveled or covered between 2 seconds and 8 seconds. Now how do we find the area of A, B, C, D? What will be its length? This will be its length. This is its length here. How much would that be? The length would be 8 minus 2, and that's 6. So this is 6 units here, the 6 units. And the breadth would be this would be the breadth of it here. I'll mark it darker. This would be the breadth, and we know the breadth is here 4 units, so the breadth equal to 4 units. So my area in this case, now this area will be length into breadth, that is 6 into 4, 24 meter. So distance covered equal to, in this case, distance will be equal to 24 meter. So distance covered between 2 seconds and 8 seconds will be 24 meter. How did we find it? We just found the distance, the area between the velocity time graph below the velocity time graph, that area. Now for the third, let's find the distance covered between 5 seconds and 6 seconds. So here is my 5 second I mark, and this is my 6 second. And now I have to find the area. So first I have to draw my rectangle or square, whatever it. So this is right up to the velocity time graph till here, velocity time graph. Now this area will give me my distance. This area enclosed will give me by distance between 5 and 6, the area enclosed between 5 and 6. And I know in this area, to find the area, I need to know length into breadth. Now what is the, here, this is 1 dimension, which you know is 1. So I'll put 1 here, say for the length, and the breadth will be along this. This is the breadth here. This is the breadth, and how much is the breadth? We see it is 4. So this is 4. So into 4. So in this case, the area will be 1 into 4, and that is 4 meter square. So distance equal to area numerically. So area is 4 meter. So this area here will be 4 meter. Distance covered, the answer will be 4 meter. So you find the distance just by finding the area enclosed by the velocity time graph. Now for the next, find the distance covered in 10 seconds. So 10 seconds means here 0 to 10. So this entire area. So here this is the area I have to find out. And now for this area, I'll just do So this area, this entire area I need to find out. This full area that is enclosed, and that will give me my distance. So for this area to find, area is length into breadth, and here this is, say I take this as a length, this whole thing is a length, and here the length will be 10, and I will take this as my breadth. This is my breadth, and that will be 4. My breadth will be 4. So the area in this case will be 10 into 4, and that is 40. So distance covered for this, distance covered in this case equal to 40 meter. Length, I repeat again, the length, which is 10 here, 10 meter, and the breadth here in this case is 4 meter. So I multiplied length into breadth to give you my area, which gives the distance covered.